Hello everyone. Today we proceed further from the last lecture. Properties of the charges. Properties of charges. First one is additive nature of charge. We can we can add charges algebraically. Whether the charge is positive or negative, we can add it algebraically. We can add algebraically. We can add the charges. It means that when the charges, suppose taken two charges, one is Q1, Q1 is 20 coulomb, and Q2 we have minus 40 coulomb. If I add these two charges, the total charges becomes on the object is Q is equal to Q1 plus Q2. Algebraically means mathematically. Mathematically we can add these two charges. Q1 20 coulomb, 20 plus algebraically minus 40. And we know that 20 minus 40 becomes minus 20 coulomb. So coulomb is the unit of minus 20 coulomb is the charge on the object, and here coulomb is the unit of charges in SI system. In SI system, coulomb, and then CJ system, we know that is strict coulomb. So second properties we have. In second property is a quantization of charges. Quantization of charges, we mean that in an object total charges will be a multiples of some elementary charges. Elementary charges, what would be the elementary charges? Elementary charges means the charges on a protons and charge on and electrons. So we know that charge on electrons and protons are mathematically plus minus. Plus is charge on the protons, that is 1.6 10 raised to the power minus 19 coulomb, and also charges on the electron is negative, so it is minus 1.6 10 raised to the power minus 19. It is the elementary particles. This is elementary particles, and so this is the minimum charges an object can have. So any object has the charge of this multiples. It means that if I take the charges, a formula, charge Q is equal to n types of any. So here n should be the integer. N is the integer. Taken the any value 0, maybe plus minus 1. If the charges is positive, take plus 1, and charge is negative, minus 2, plus minus 2. So this goes to infinite. So it is Q is equal to any. So any object can have the charges of the multiples of this minimum charges, that is E. Okay, this is according to the classical physics, but modern physics can say something else. So since the value of E, very small charges, so generally it is not practically not observable. If I calculate the charges, suppose 1 coulomb. If I take, suppose Q is equal to 1 coulomb, how many electrons this 1 coulomb is made of? If I calculate this value comes out very huge one. So let us suppose calculate this one. Q 1 coulomb, number of electrons or protons. I mean that it is the positive charges. We have said it will be the proton charge on the protons, and multiplied E 1.6 10 raised to minus 19. If I solve this one, so number of protons made of 1 coulomb will be n is equal to 1 divided by 1.6 10 raised to minus 19, and here 10 raised to minus 19. If I replace decimal point, it becomes 10, and 10 raised to 19 goes in the numerator. So divided by 16. If you divide this one, this value comes out approximately. We can get exact values of this ones. So 2, 8, 16, and 5 and 5 on 8. If you solve these ones, taken decimal 50 and 60, 48, 20 are gonna show lot 20 and this is the value plus 19. Now finally this value comes out. If I remove this decimal, 6 to 5, 6 to 5, 10 raised to the power 16. So it means that one coulomb has 625 power 10 raised to the power 16. So that much of protons is included in 1 coulomb. So practically this is a very huge quantity. We cannot observe these ones. So normally we the charge in an object can be in a continuous process, because this is very minimum quantities. We cannot observe these ones. So by quantization method, any object cannot have the charges in a fraction like E upon 5, E upon 7. Such type of charges cannot be have in an object. But practically we cannot observe. This is a very small quantity, E upon 5, E upon 7. We cannot observe if the charges, suppose any charges in an object, but it is observable if the charges is a very minimum, like in this orders 10 raised to the minus 19 coulomb. Okay, if the charges is in this order 10 to the power minus 18 coulomb, this is very less amount. So in this case, if the charge is very small, we can notice it. The charge is quantizable, but if the charge is like 1 coulomb, more than that, around that of, so we cannot observe. It is observed that the charge is quantized. So in the modern physics, the charges have less than that of these ones. So that is known as quark. Quark. This is the word we can learn in, but this is some subtopic. Now quark. The quark, normally the protons made of proton and neutrons, which are part of the nucleus, they are made of quarks. So there are two types of the quarks. There is one upper quark. Upper quarks has the values 2 upon 3 E. So if I not take electron is the elementary particles, if I take quarks is the elementary particles, which suggests the modern physics. So this is once again is quantized, and there are a lower quark also. Lower quark has the value minus E by 3. It has the negative charges. So it means that the minimum charges on the elementary particles should be E by 3. Okay, this is again quantized. E by 3 is the minimum charge. So every object can have the multiples of E by 3. So this is known as quark method, modern physics, and it is a subtopic. But still we consider electrons and protons are the elementary particles. So this is the case. If I take the protons, proton has charges 1e. So 1e made of 2 upper quark and 2 upper quark U and lower D for upper quark. We normally represent upper quark for U and lower quark for D. Okay, so UUD. It means that if you add twice E by 3, next U twice E by 3, and plus D has the value minus E upon 3. If you simplify this one, this value comes out plus E. So it means that protons are made of 3 quark UUD, and neutrons are made of, if I take the case of the neutrons, one neutron is made of again 3 quarks. It will be upper quark, 1 upper quarks and 2 lower quarks. If I calculate the value, value comes out U is twice E by 3, and down quark, that is the lower quark, will be minus, if you add minus E by 3 minus E by 3. So because neutron has no charges, twice E by 3 minus twice E by 3. So total charge on the neutrons is equal to 0. So since neutron is chargeless particles, it has only masses, and the mass of the neutron is more than that of another protons and electrons. So that's why if I consider other than the electrons as an elementary particle, we can consider E by 3. E by 3 will be the elementary particles. Okay, but still we are considers only the electrons are the protons are the elementary particles whose value is this one, plus minus 1.6 10 raised to the minus 19 coulomb. Now third property of charges is conservation of charges. So in this one, the charge cannot be created or destroyed in any way. Charge only transfers from one object to another object by physical method. So like we have did in the induction method, and also inductions and frictional electricity when you rubbing two things like glass rod and silk cloth, and another one is by yes by induction, by conduction, and by friction. So we have observed that the total charges is same. So we can say that the charge neither created nor destroyed. The charge always remains constant. So it is neither created nor destroyed. So I have taken some examples of the same thing. Glass rod, when we are rubbing glass rod, this is our glass rod initially made of glass, no charges it has, and if I take silk, this is the silk cloth, this is the silk cloth, it has no charges. So initial charges Qi, initial charges Qi is equal to 0. So Qi is equal to 0 when we rubbing, after rubbing, okay, after rubbing they got after rubbing to each other. So we see that these two objects get some charges. So that charges, glass has, suppose glass, since glass transfers some electrons from some electrons to silk cloth, and since silk is initially neutrals electron gaining by the silk, that's why the silk becomes negatively charged. So here the glass rod getting the positive charge because it loses some electron, suppose and this is our silk that thick है, so it gains some electrons. So we have, so practically if I check, so suppose it has some charges, so how much the charges, suppose the positive charges come on this glass rod is equal to, let us suppose 2 coulomb, and same amount of charges but in negatively will be on the silk cloth. So silk cloth should have minus 2C. So the total charges after rubbing and after rubbing will also be same as that of the initial one. So final charges become initial Qi equal to 0, final charges if I add in this isolated system, okay, there is no other charge body nearby of these ones, so we consider only this is an isolated system. The Q finals twice coulombs on the glass and the negative charge on the minor 2C. So by the additive nature of charges we can add these algebraically, 2C and minor 2C cancel out 0. So final charges would also become 0, initial 0, final become 0. So we can say that charge is conserved in this example. Now take another example. If I take examples from nuclear physics, in nuclear transformation, so when we bombarded a uranium atoms with slow moving neutrons, so this is the fission reactions. So from the nuclear energy, if I take this example, so it becomes clear that the charges again is conserved. So here the example is uranium 92. Uranium 92 is the atomic numbers of uranium 235. 92 235. when bombarded slow moving neutrons, so we get some byproduct of this one. One is kryptons, another is uh, barium. So we get after barium plus krypton plus 3 neutrons, 3 neutron, and plus a lot of energy. Q value means uh, energy of the kinetic energy of the barium, krypton, and the neutrons plus some heat radiations. So this will be the total energy. Some mass also converted into energy. Let us do later. So in this chemical reaction, this is our nuclear reactions in which uranium is bombarded with the slow moving neutrons. We get barium, krypton, and 3 neutrons plus some amount of energy. So here the barium has atomic number 56 and atomic mass 141, and 56 it has 36, and atomic mass it has 92. So 92 is the atomic mass of the kryptons plus 3 neutrons. So here we can see that the number of proton resides in the nucleus, and electrons are orbiting. So we have protons or electrons are conserved. Before that we have total protons or total protons or electrons. Before that we have protons and electrons are 92 plus 0. Okay, neutron is chargeless particle, 92 plus 0, and after that barium have 56. So the atomic numbers should have 56 protons or electrons, and krypton 36 protons or electrons, and the neutron has no charged particles. If you add these two again, so we will get 6 plus 6 12, 5 3 8 and 92 again. Okay, we once again get the number of same number of protons or electrons. So in this nuclear reactions, so charge is conserved. There is no creations, not destroying any charges, only we have transfers. We have transferred some physical methods. So another example, if I take another examples in which gamma particles is chargeless massless particles. It is electromagnetic photon particles. So if gamma particles split it, we materializes gamma particles like this ones. So this is our gamma particle. Gamma is a photon particle. Since we know that light made of the these particles, photon particles, when split it, so we get two particles. One is electrons. Electron has negative charges, and plus another one is a positron. Positron will be its antiparticles. If I take yes, so total charges on the electron minus E, and on the positron is plus E. So this is positron. Positron is the antiparticles of electrons. So both are antiparticle of each other. So total charges are once again become. So again here we can say that the initial charges on the photon is 0. Total charges after splitting, materializing the photon into two particles is minus E and plus E, once again 0. Similarly, we have this is known as the pair production. This is known as pair production. So in this case we have produce two antiparticles simultaneously. Similarly, in pair annihilation, we can combine positron and electrons. We get two photon particles. Okay, so it is known as a pair annihilation. Pair annihilation. We have removing the existence of two positron, two materialistic particles, two physical particles. So this is known as pair annihilation. So now in pair annihilation, one positron, if I take positron plus and one electrons. When they are combined, they may becomes two gamma particles and one gamma particles, because gamma particle is this gamma particle should be different of this gamma particle, because if it made of two gamma particles, it means that their energy, this this gamma part this gamma particles are different than that of energy. Okay, energy would be the different one. So in this way it's known as pair annihilation, because two physical particles are changed into the energy. So Einstein's also given a relationship between mass energy relation. This is known as mass energy relation. In this case, mass energy relation by Einstein's, in which every energy is converted into mass by this relation. If a mass is okay, an object whose mass is m, if it converts into energy, so that amount of energy would come out. So same thing is happen. There is positron and electron both have masses, and they converts into the energy, because gamma particles is a photon particle. It has no mass and no charges, because it only carry the energy. So this is the energy particle. We can call this is energy particle. So in this case, this is a pair annihilations. We can see that total charges before is again 0, after the combining these positron and electrons once again 0. So in this way, the total charges in any object, any isolated system of object should be 0. Should conserve, not 0. It should conserve. Okay, it cannot destroy, not create it. It only transferred from one object to another object, and this is where we have discussed the properties of the charges.